Here I want to study the motion of a multiple connected objects, and especially the condition that you have to respect in this case. I want to draw here many case of multiple connected objects, and I write to the left all the conditions that you have to respect for all these cases. Okay, first of all, I take case 1. Let's say we have block A, B, and C. We have A and B are connected by one cord, and B and C are connected by another one. This is the first case. These objects are connected by 2 cords. The second case here, 2. Let's say here we have the same horizontal table, and A, B, and C are connected, are in contact directly. Okay, this is a second case. And the third case, we have A, B, and C in this position. Maybe you have 3 objects or 2 objects. Okay, it depends the problem. But I am studying here the case where the objects are in the same direction, on the same plane. We don't have 2 dimensions here. All these cases are studied where the motion is in the x direction. Okay, maybe we can have an inclined plane, and these objects move on the inclined plane. Okay, but they are in the same direction, like this or like this, whatever. Okay, let's write the conditions that we have to respect, the common conditions of all these 3 cases. A, the acceleration is the same for A, B, and C. Before the acceleration, let me see about the chord. The chord is massless and inextensible, inflexible. It's important. In all our chapters here, we take a massless and inflexible chord. It's the first point. B, the acceleration is the same for A, B, and C. A for A equal A for B equal A for C. Point C, the speed is the same for A, B, and C. VA equal VB equal VC. Sure, here, let's say we have a force applied on the block C. We push the system to the right, like this. And here on the block A, for example, this one is F. Here we have F. Okay. So in these cases, the acceleration must be to the right. Let's say here we have the acceleration to the right in these cases. And also the speed, the velocity is to the right because we have a increasing in the velocity. Here we have V, okay, the blue one. And here we have A as acceleration. A is the same for each object. Okay, this is a point C. Let's take point D. In the point D, we can apply Newton's law, for example, F equal ma, on the whole system and or the individual system. Object. What I mean by this point, I want to take the first case, okay? In this case, here we have ABC connected by two curves. We can apply Newton's second law on each one. For example, here we have A, let's say we have the tension T. Here we have, for example, T. Okay, here we have TA. We have the weight MA. We have the normal NA. So we have NA. We have MAG and the tension. We can apply Newton's law on the object A. And don't forget here, I push C with F. Okay, with F. So summation of F on the object A, F is applied on C. We cannot take F into account. Okay, I am talking about A. Equal, we have TA plus MAG plus NA. Okay, I take only one object. We can do the same calculation on the object B. We can say here we have TB on the object B. We have MBG and we have NB, and here we have a tension T prime B. So we can write here we have NB, we have TB prime, and here we have TB and MBG, the weight, and NB. We can write Newton's second law. So this one for the object A. Now for the object B, we can write here. For the object B, we can say TB plus T prime B plus MBG plus NB equal MBA. Okay. Also here we can write equal MAA. So this is for the object B, we can apply Newton's law on the object C. So about the individual object, we can apply Newton's law. Also, because these objects are connected and they are moving in one direction, we can apply Newton's law on the whole system. So this system is A plus B plus C. We have here the total weight M capital G. We have the total reaction N. And here, be careful that we have F. What we do when we take the total system? We have to eliminate all the internal forces in the object. I want to show the internal forces. Between A and B, we have one internal, we have TA and TB, we can eliminate. Between B and C, here we have TC, we can eliminate T prime B and TC. These are internal forces between them. But F is external, okay? I use an external F to move all the system. When I talk about the whole system, we have to talk only about the external forces. We cannot talk about the internal forces. So we can say here we have F applied on the system. Let's take the same color F on the system. Okay, here we have F. We can apply Newton's law. Summation of F on the system equal mg of all the system mg, and you know that m equal ma plus mb plus mc plus n, the total reaction n, equal ma. Okay, this is the total equation of the system. So we can add to the condition C 1 point that we have to eliminate the internal forces when we take the whole system. So it's very important, this point. So we eliminate the internal forces. I think we have one more condition. I want to add this condition here. Okay, it's the condition A, B, C, D, E. For one chord, the tension is the same for both objects. Okay. If we take the first case, we said here we have a tension between A and B. We have one chord. We have TA and TB. For the same chord, we must have the same T. So they have the same T as magnitude. We have T equal to T, but they are opposite in direction. We can take another chord between B and C. Between B and C, we have T prime B and T prime C. Here we have T prime and T prime. But be careful, T doesn't equal to, E is not equal to T prime, because you have two different chords. When we talk for the same chord, T, the tension is the same, like here. Okay, it's all about the conditions that we have to respect in the case of multiple connected objects, and we can go to the application and to solve each problem alone. Thank you.